So part 6 of chapter 1, last part. We're not really doing anything new in this one. We're just going to continue practicing dimensional analysis. I'm just going to make the problems a little bit more difficult because real life isn't always just a one-step process. So we're just going to continue doing dimensional analysis. And again, as we're working through these, if you've got questions, please don't hesitate to let me know. I'm always happy to do more examples. So we're going to start with a dimensional analysis problem that takes more than one step, because sometimes we don't have a unit factor going directly between the unit that we're solving for and the unit that we're starting with. Real life isn't so clean. So let's just run into one of those situations. The good news is we don't really change, we don't change how we do these problems. All that's going to happen is we're just going to add a second unit factor, a second fraction, next to the first one until I can get my units canceled until the one left is what I'm solving for. So it's not a big deal. It's fine. I promise. If you can do the one-step ones, I know you can do a two-step one. So let's read this problem, and we're going to try it just like we did our other ones. So first we read the question. An unknown sample in the lab weighed 1.962 mgs, which are milligrams. What is the mass in units of pg, which P stands for pico, which is one of the metric prefixes that you are not required to memorize, but is on a metric prefix table in the textbook. So since it's not one you have to memorize, I gave you the unit factor for that one. 1 gram is equal to 1 times 10 to the 12th picograms. So notice I did not tell you anything about milligrams because that one's expected for you to know. So what we're supposed to do with dimensional analysis problems, we read the problem. Awesome. Figure out what unit are we solving for. The question says, what is the mass in units of picograms? So picograms is what we're solving for, so I'm going to write that down. Next, we're going to figure out, well, what are we starting with? What were we given? Well, 1.962 milligrams is what we were given. And then next, we need to know, well, what are the unit factors between these units? Well, we were given one unit factor. 1 gram equals 1 times 10 to the 12th picograms. We were not told anything about milligrams, though, so that's on us. So 1 gram is equal to 1,000 milligram. And you can write 1 times 10 to the 3rd milligrams, and that is glorious. If you like the negative exponents, you can say 1 milligram is equal to 1 times 10 to the negative 3rd grams. That is also a wonderful unit factor. To me, it just makes more sense for there to be 1,000 little milligrams that add up together to equal 1 gram, instead of saying 1 milligram is 1/1000th of a gram. But everyone's brains are different. Use what works for you. Either way, we'd have to know this unit factor. Okay, so we now have 2 unit factors. I'm going to go with this one. It's the one I'm going to use for the milligrams. And then this one is the one that we were given for picograms. Okay. So in our one-step processes, we only had one unit factor, and so the big question was, well, what unit goes on top and what unit goes on the bottom? We're still going to have to answer that, but now that we have 2 unit factors, we also have to decide, well, which one do we use first? Well, just remember, the whole point of figuring out what unit goes on top or bottom is to cancel out the unit that was given. So of those 2 unit factors, only one of them, this one, has milligrams in it. So that's the one we have to use first, because the milligrams have to go on the bottom in order for it to cancel. I can't use the 1 gram equals 1 times 10 to the 12th picograms at all right now, because neither of those units will cancel. Neither of those units is the unit that we're trying to put on the bottom. So I have to put 1,000 milligrams on the bottom and 1 gram on the top. So I'm going to go ahead and cancel out my units that can cancel, cross out the milligrams. So the units that I have left are grams. So what we're waiting for is for this unit to match this unit. Well, we're going to keep waiting because grams and picograms are not the same thing. So that's how I know it's going to be a 2 or more step problem. I also know in this case because I have 2 different unit factors. So what we're going to do is just continue on. The unit that I have that I need to cancel out is grams. So I know that that unit needs to go on the bottom. Grams are going to have to go on the bottom down here. I've already used this unit factor, so we're done with that. So now we're going to use the 1 gram equals 1 times 10 to the 12th picograms. And when I set that up, the 1 gram has to go on the bottom. So I'm going to cancel that out. The unit that is left is picograms, which is also the unit we're trying to solve for. So that's my sign. It's time to grab your calculator. I'm going to take 1.962 times 1 times 10 to the 12th divided by 1,000. I know there were ones in there. Remember, I ignore the ones. Okay, so what I got on my calculator was this. So let's think significant figures. I want purple. 1.962 has 4 significant figures. Makes me so sad that my pen's being so gross. 1 gram and 1,000 milligrams is a metric prefix table 1, so it has an infinite number of sig figs. And 1 gram is equal to 1 times 10 to the 12th picograms is also an infinite number 1 because it's a metric prefix thing, and so infinite sig figs. So which one's smaller, 4, infinity, or infinity? Well, our answer is 4. So this should have 4 sig figs. If we look at it right now, 1, 2, 3, 4 sig figs. It looks great. Just so you know, the times 10 to the whatever do not impact significant figures. Okay. So this, in this case, I don't have to do anything to it. That's my answer. Okay. Let's try another one. A rolling cart has 8.622 times 10 to the third kJ. So K stands for kilo, J stands for joules. That was the unit for energy we talked about earlier in the chapter. We're supposed to convert this to CAL, which stands for calories, which is another unit of energy. And we're told 4.184 joules is equal to 1 calorie. That's awesome. We weren't told anything about kilojoules, though. So 1 kilojoule is equal to 1,000 joules. You could write 1 kilojoule is equal to 1 times 10 to the third joules. That's coming from the metric prefix table with kilo. I'm looking in the kilo row, and I'm replacing meters with joules. Because remember, metric prefixes, we can use any unit we want. So now we've got to go through our process of doing our dimensional analysis. We need to decide what unit are we solving for. Well, it says convert this to calories, so calories. Well, what are we starting with? Well, the measurement they made was 8.622 times 10 to the third kilojoules, so that's what I'm starting with. And I have 2 unit factors, this one and this one. Which one do you think I'm going to start with? Unit factor 1 or unit factor 2? Well, I need to start by canceling out kilojoules. So of the options, this is the only one with kilojoules, so I'm going to start with unit factor 1. 1 kilojoule on the bottom, 1,000 joules on the top. I made the decision because I needed to cancel out this unit with another one of those units. Oh my gosh. There, I go real fast, it's fine. All right, I'm going to cancel out kilojoules. Bam. Now if we look, our answer. Well, the unit that's left is joules. Is that what I'm supposed to be solving for? No. So I know I'm not finished yet. Trying to erase you. Okay, so I'm done with that unit factor. I've already used it. So the unit factor I have left is 4.184 joules is equal to 1 calorie. I need to set this up so that way, so joules are at the top, they need to be on the bottom. So 1 calorie on top, 4.184 joules on the bottom. I can now cancel out the unit joules. Okay. The unit that's left is calories, which is the unit I'm solving for, so I don't have to have any more steps. Now it's time to grab my calculator. I would take 8.622 times 10 to the third times 1,000 divided by 4.184. When I do that, that's what I get. A whole bunch of numbers. Now we need to think significant figures. So we're going to go back and look at all of our steps. 8.622 times 10 to the third kilojoules. Well, that has 4 significant figures. 1,000 joules is equal to 1 kilojoule. Didn't that come from the metric prefix table? So that's infinity sig figs. And 4.184 joules is equal to 1 calorie. I know that 1 makes it look like there's only 1 sig fig, but when I look at 4.184, 4 sig figs. So which one's smaller, 4, infinity, or 4? Well, 4. 4 sig figs. So when I look at this, 1, 2, 3, 4. So do you think my answer is 2061? I'm going to round the 0 up because it's followed by a 7. 2061, do you think that's my answer? Does it make sense when the calculator said 2,060,707.5 calories, and when I rounded to sig figs, now it's magically 2,061? Wouldn't that be glorious if when you're like eating and you eat a whole bunch of candy and you're like, oh my gosh, this was a whole lot of calories. Well, I'm going to round it to the correct number of sig figs, and it's going to go down to like, instead of 4,000 calories, it's going to be 4. Yeah, friends, no. We can't just stop there. We have to show the magnitude of the number. Remember when we were doing significant figures and zeros at the end of a number are not significant as long as there's no visible decimal place? Look what I just did there. That 1 looks like a J and it's really bothering me. There. This number, 2,061,000 calories, has 1, 2, 3, 4 significant figures. So that would be the correct answer. The other option is to write it in scientific notation. I didn't plan my space very well. So in scientific notation, Well, that should be a 1. I screwed that one up. I know I'm whining about my pen. I'm sorry you guys have to hear that. Both of these would be correct answers with the 0 replaced with the 1 there. That was a typo on my part. Unless the question specified, I don't care if it's in scientific notation or not. So both of them would get you equally full credit. But if the question said to put it in scientific notation, then you need to have it in scientific notation. If the question said to not put it in scientific notation, then it needs to not be in scientific notation. But if the question was worded exactly like it is on the slide, both of them are equally correct. Okay. So this is what I'd like you to practice. So what I want you to do is I want you to read these 2 questions. I want you to then pause the video, and I want you to do both of these problems on your own. And then unpause the video and see how it's going. You're going to be really tempted to not do that. You're going to be super tempted to be like, all right, dude, no. I've got a lot going on in my life right now. It's not worth the time. This is stupid. It's supposed to be you lecturing. Yeah, okay. I don't care about all those excuses. Do you want to do well in here or not? If the answer is yes, then it's worth it for you to take the time and practice this, because this is how you know if you understand what's going on so far. So even if you're not able to do it right this minute, you need to come back and do this. Because chemistry is not one of those things that it just works through osmosis. Number 1, osmosis is biology, so no. Number 2 is chemistry's problem solving. So you've got to practice solving the problems to get good at it. So after my, mini rant, just pause the video, try both of these problems. After you've had a chance to try them, come back and I will go through the answers. Well, that worked out perfectly for me because I had to go fix a computer issue for my 8-year-old. So hopefully you had a chance to give these a shot. Let's go through them together. So the first question, convert 3.559 times 10 to the 17th nanometers to meters. Well, I want to solve for meters. So I'm going to, no, sorry. I'm yelling at myself, not you. Meters. And I'm starting with 3.559 times 10 to the 17th nanometers. And now I need to do the math. Well, I need to have a unit factor, and it wasn't given in the problem. There's your hint that it's from the metric prefix table. So on the metric prefix table, 1 meter is equal to 1 times 10 to the 9th nanometers. So now I need to put that as a unit factor, as a fraction, and I need the nanometers to go on the bottom. So 1 times 10 to the 9th nanometers goes on the bottom, 1 meter goes on the top. I'm going to cancel out nanometers. The unit that's left is meters. The unit I'm solving for is meters. So it's time for me to grab my calculator. 3.559 times 10 to the 17th divided by 1 times 10 to the 9th. Now, if at the end of this you got a different answer than me, it's probably the way you're entering it into your calculator. And so if that's the case, either do a quick Google online or send me a picture of your calculator and tell me how you're doing it, because every calculator is different. But I want to make sure your calculator is not causing you to get the wrong answer. So, correct answer here, 3.559 times 10 to the 8th meters, or you could also write that like this. Both of them have 4 significant figures because 3.559 has 4 sig figs. 1 meter is 1 times 10 to the 9th nanometers is infinity sig figs. 4 is smaller than infinity, so there's our answer. Second one, convert 7,259.0 micrometers to kilometers. So I'm solving for kilometers. And I'm starting with 7,259.0 micrometers. And it's time to math. Well, I don't have any unit factors, so again, we got to think. It's from the metric prefix table. I'm going to draw a line right here. Okay, so 1 meter contains 1 times 10 to the 6th micrometers, and 1,000 meters are in 1 kilometer. Those are my 2 unit factors. So when I set this up, I'm going to choose the one that has micrometers in it because I need to cancel out micrometers by putting them at the bottom. So I'm going to set this up by putting 1 times 10 to the 6th micrometers on the bottom and 1 meter on the top, and I'm going to cancel out micrometers. Now I have units of meters, and I need to solve for units of kilometers. Well, those aren't the same. So that's how I know I have another step. Plus I had 2 unit factors. So I've already used this one. So the unit factor I have left, 1,000 meters is 1 kilometer. Well, I need to put meters on the bottom. So I do. This is in kilometers. This is in kilometers. Okay, so it's time to grab my calculator. 7,259.0 divided by 1 times 10 to the 6th and divided by 1,000. So my answer is one of these two things. Pause first. Hold on, before I write the answer. Let's look at sig figs. How many sig figs does 7,259.0 have? Hopefully you went with 5. That 0 is significant because we have a visible decimal place. This is infinity. This is infinity. So my answer is going to have 5 significant figures. So we could write it in decimal form. 0.000072590 kilometers, or 7.2590 times 10 to the negative 6th kilometers. Both of those are equally correct. If, again, you got something very different, but your setup looked correct, then it's something going on with your calculator, so let me know, because I'd be really happy to help guide you through doing this on your calculator. But I need to know what kind of calculator you have, so I need to have a picture of your calculator. So send me a message in Canvas with a picture of your calculator, and kind of you talking me through what buttons you pushed so I can figure out what to help you with. Okay. Yay! All right. So we're just going to do some more examples. This one is going to be our longest one so far. We're going to do this one together. Calculate how many inches are in 4.2 miles. And the given information is 1 inch equals exactly 2.54 centimeters. 1.6093 kilometers equals 1 mile. So this is the first time we've seen me write the word exactly in a unit factor. That's my way of telling you this has an infinite number of sig figs. Okay, because in other unit factors, that looks like 8. My infinities are horrible. Nope. Does that look better? Stands for infinity. Because otherwise you'd look at that and think it has 3 sig figs, but unfortunately, that's not how inches and centimeters work with our unit factor. So when I write the word exactly in there, that's me telling you it has an infinite number of sig figs. In the other one, 1.6093 kilometers equals 1 mile. We're just going to count sig figs on this one. This one's going to have 5 sig figs. Okay. So other than the exactly word, nothing about this is any different. We need to calculate how many inches are in 4.2 miles. So my answer needs to be in inches, and I'm starting with 4.2 miles. And I have unit factors, multiple unit factors, but I'm going to choose the one that has miles in it because I need to cancel out the unit miles. So I'm going to start with this one. I'm going to put 1 mile on the bottom and 1.6093 kilometers on the top, where I can cancel out the unit miles. So if I stopped right now, my answer would be in kilometers. Is that what I'm looking for? No. And I know that because what I'm looking for is inches. And that is not what I have. So I know I need to cancel out kilometers. Well, if we go back and look at our unit factors, we weren't given anything about kilometers. That's because kilometers is one of those metric prefixes. 1 kilometer is equal to 1,000 meters, which is the same thing as 1 times 10 to the 3rd. So that's going to be my next unit factor. And I need to put kilometers on the bottom. Cancel out kilometers. So now I have the unit meters. It's awesome. Am I done? No, because I need inches. So I need to cancel out meters. Well, oh my gosh, there's so many things that can cancel out meters with, like an entire metric prefix table. Well, we've used this. We've used this, right? We know we need to eventually get to inches, like that. Well, according to this unit factor, don't I have to get to centimeters before I can get to inches? So let's go from meters to centimeters. 1 meter is 100 centimeters. That gets me in centimeters, which means I'm still not done. But I can finally use that last unit factor. 1 inch equals exactly 2.54 centimeters. So I can put 2.54 centimeters on the bottom and 1 inch on the top. And I can get myself a number in my calculator. Okay. But now we need to think about sig figs. So I'm going to look at each step along the way and count the number of sig figs. 4.2 miles, 2 sig figs. 1.6093 kilometers is 1 mile, is 5 sig figs. 1,000 or 1,000 meters is 1 kilometer is infinity sig figs. 100 centimeters in 1 meter is infinity sig figs. 1 inch is equal to 2.54 centimeters. You originally would think 3, but remember it has that word exactly in there. So it's also infinity sig figs. So 2, 5, infinity, infinity, infinity. Which one is the smallest? Well, 2. So 1, 2. Do you think my answer is 27? I hope you don't think that, because this is 266,104.7244 inches. And if you just said, oh yeah, it's 27 inches, that's super, super different. So your two answers could be 270,000 inches, where there's no decimal place at the end, making those zeros not significant, or writing it in scientific notation. Both of those are excellent. Okay. So we've got some more scenarios that can happen with dimensional analysis. This next one is conversions involving complex units. So complex units are things, a measurement or a value that has 2 units inside of it, like miles per hour. Isn't miles its own unit and hours its own unit, but miles per hour has both of them in it, or meters per second, or grams per milliliter, or any other scenario you can think of that has 2 units in it. That's a complex unit. So here's a real difficult question. If you're driving down the road at 72 miles per hour, and you drive for 72 miles the whole time, you're going 72 miles per hour, and you drive for 72 miles, how long did you drive? 1 hour? Or I can ask it another way. I'm going 26 miles per hour. I've been driving for 1 hour. How many miles did I go? 26. So when we have something like a complex unit, we instinctively know that what it's saying is 72 miles in 1 hour, or 26 miles in 1 hour. That hour has a 1, right? 72 miles per hour. It's implying that per 1 hour. We just don't say that. So what I just did was I took a complex unit thing and I wrote it out like a conversion factor, which I could then use as a unit factor. Now, the 72 miles per hour conversion factor, I can only use it when the speed of the situation is 72 miles per hour, but it is a unit factor. So that's what conversions using complex units is doing. It's just taking a measurement like that and using it to convert miles to hours or hours to miles. Okay. So I used another example here, which is density, grams per milliliter. Well, the density of gold is 19.3 grams per milliliter. That means 19.3 grams in 1 milliliter. So I can write 19.3 grams over 1 milliliter, or 1 milliliter over 19.3 grams. Because remember, unit factors always have 2 fractions. Sorry, I couldn't write and talk at the same time. That's me converting that into something that's familiar. We just put a 1 next to the bottom unit, and then I can use it like a unit factor. Okay. So let's try one. These start getting more tricky for people because there's more numbers in the question, and that's where it gets weird. But it's going to be fine. We'll talk through it. So calculate the mass in grams of 1.00 quarts of benzene. The density of benzene is 0.879 grams per milliliter, and we're told 4 quarts is equal to 3.7854 liters. Whew. Okay. What are we solving for? It says calculate the mass in grams. So grams. What are we starting with? Oh man, there's a lot of numbers. Well, calculate the mass in grams of 1.00 quarts. That's one big hint. Immediately after telling me what it wants the units of, it tells me of what? 1.00 quarts. So that's going to be the thing that we're starting with. The other way that I know that, if you didn't read that question and get that from the language, you're never going to start with a unit factor unless all you're given are unit factors. So unit factors are either things like this, something equals something, or didn't we just say that these complex units are also unit factors? 0.879 grams per milliliter means 0.879 grams in 1 milliliter. So I'm not starting with that either. So I'm going to start with the 1.00 quarts. Now I'm just going to cancel my units and carry on with my day until I get to grams. So I need to cancel out the unit quarts. So looking at my unit factors, which I have 2 right now that I have visible, I'm going to use the one that was in the parentheses that has the quarts. So I'm going to put 4 quarts on the bottom, 3.7854 liters on the top. Cancel out quarts. Awesome. I have liters. I need grams. I'm not done. So I look at the unit factor I have left. 0.879 grams equals 1 milliliter. I can't use that yet. That's liters. This is milliliters. We weren't told anything about that. Well, dang. We need to remember from our metric prefix table that 1 liter has 1,000 milliliters if I look at the milli section of the metric prefix table. So when I set this up, liters needs to go on the bottom, so it'll cancel. So now, my answer would be in milliliters, which is still not the same for what I'm looking for, so I know I'm not done. So we still haven't used our last unit factor, 0.879 grams equals 1 milliliter. Well, we can now, because I have milliliters. I can put milliliters on the bottom, 0.879 grams on the top, and cancel that out. The unit I have left is grams, which is what I want. So that's my clue. It's time to grab my calculator. 1.00 times 3.7854 divided by 4 times 1,000 times 0.879. This is what I get. Let's think sig figs. Okay, so 1.00 quarts. That has 3 significant figures. The zeros are significant because I have a visible decimal place. 3.7854 liters equals 4 quarts. 1, 2, 3, 4, 5 sig figs. This is an infinite number of sig figs. And this one would be 3 sig figs. So 3, 5, infinity, 3. Which one's the smallest? 3. So my answer should be 832 grams. Hopefully we're feeling okay. I know where it gets confusing is the fact that in the question it looks like we were given 2 numbers. Whenever you're given something that's complicated like that, and if you were given something that's not complicated, start with the not complicated. Start with the easy one. Okay. So, next scenario. What happens if we're dealing with units that are raised to a power? Like centimeters squared or centimeters cubed, decimeters squared, decimeters cubed. I have cubed units to the 3rd power on here because those are the ones we deal with the most because that's volume, and volume's a thing we make measurements of. Squared is area, and we don't, in chemistry, spend a lot of time with area. I can't say none, but in this class I can pretty much say none. You might run into something squared, but not very often. So if I wanted to convert from a measurement that was in centimeters cubed and convert it into inches cubed. The only unit factor I can find for that is 2.54 centimeters equals 1 inch. But if I did centimeters cubed, centimeters, inches, can I cancel out centimeters cubed with centimeters? Like cancel it out completely? No. Wouldn't I be left with centimeters squared? And that's not the point of dimensional analysis. The point of dimensional analysis is to get rid of units and replace them with other units. So when we have this situation, we have to be clever. We have to be smart. Okay, so if I need to go from centimeters cubed to inches cubed, but all I know is 2.54 centimeters is equal to exactly 1 inch, to fix this unit factor, I need to cube the whole thing, and then I'll have a unit factor between centimeters cubed and inches cubed. So here's me doing that. What I like to do is write it more like this first one, and then I deal with the math in my calculator. But if it would help for you, you just have to notice that when we cube it, it's going to be everything, the units and the numbers. So here I've separated out the units. This went from centimeters to centimeters to the 3rd power, inches to inches to the 3rd power. Then I did 2.54 to the 3rd power and 1 to the 3rd power. This is what I got when I did that. So I can either replace this unit factor with that one, or when I do my math, kind of write it here and do the cubing thing in my calculator later. I like the cubing at my calculator later, mostly because I'm lazy. So let's give this a shot. Okay. If the volume of an object is reported as 5.0 cubic feet, feet to the 3rd power, what is the volume in cubic meters, which means meters to the 3rd power? And we're told 5,280 feet is equal to 1.6093 kilometers. Okay. So what unit are we solving for? Well, meters cubed. And we're starting with 5.0 cubic feet. I need a unit factor that lets me cancel out cubic feet. This is not exactly that unit factor. So 5.0 feet cubed. If I put 5280 feet, so 1.6093 kilometers. When I go to cancel, I cannot cancel out all of cubic feet with feet. That's not how that works. I can cancel out one of the feet, left with feet squared. So I'm going to have to cube the entire unit factor. So that's what I did here. Now I'm going to have to later distribute this cube to all these pieces. But for right now, The fact that it's got parentheses around it and I've got cubed around it is telling me that this is going to be feet cubed. Okay, which would leave me in an answer that's so that's in kilometers. My unit is kilometers cubed, which is not the same thing as meters cubed. So 1,000 meters equals 1 kilometer. That's awesome, but this is kilometers cubed. So when I go to set that up, I can't just leave it like that. I have to also cube it. So again, if it would help you, distribute that cube to each of the pieces. Take 1.6093 to the third power in your calculator and write km to the third power. And then take 5280 to the third power in your calculator, write that down, and write feet to the third power there. On this one, you can take 1,000 to the third power and write that down, meters to the third power next to it, 1 to the third power, which is 1, and kilometers to the third power. That gets me the unit that I'm looking for. So if you do what I've done, which is just write the cubed around it, so when you put it in your calculator is when you have to actually raise it to the third power. Like we have to actually do that. Okay. So this is what I got. So let's look at sig figs. 5.0, 2 sig figs. This one, 1.6093 has 5. 5280 has 3. I'm going to go with 3 sig figs. This one's infinity. So 2, 3, infinity. 2 is the smallest one. 0.14 meters cubed. If this one's blowing your mind, okay, good and bad news. Bad news, we still have to know how to do it. Good news is we don't use this one as often. But just let me know if you want some more examples on this one, though. Last scenario. Okay. Last scenario is if I need to convert a complex unit to a different set of complex units. So instead of using a complex unit like a unit factor, let's say I'm driving 72 miles per hour and I need to convert that to kilometers per second. Well, crap, I have to do the math with that number. So the good news is this really isn't any different than everything we've done. We just have twice as many units going on. So the most important thing is every time we see complex units. So 76.0 miles per hour. I wrote that out, but what that's saying is 76.0 miles in 1 hour, right? Isn't that what that's saying? Well, when we see complex units, we need to write them like that. 76.0 miles per 1 hour. You need to actually put the 1 with the second unit. And the second unit per means it's in the denominator. Okay. So I was driving 76.0 miles per hour. Calculate that speed in units of decimeters per minute. So we need our answer to be in decimeters per minute. So I'm going to write my answer needs to be in decimeters per minute, and I'm starting with 76.0 miles per hour, and when I write that, it's going to look like this. If you don't write the fraction and then the 1 hour at the bottom, you're going to do something bad as we go through this. Okay, so let's work through it. So what I do is I'm going to pick one unit and work on converting that. So miles needs to become decimeters. Hours needs to become minutes. Those are two separate processes. I have to do both of them, but when I start, I'm not going to try to do both at the same time. So what I'm going to do right now is I'm going to ignore hours. Not forever, just for right now. Okay. And my goal in life right now is to convert miles into decimeters. So we were given one unit factor. 1 mile equals 1.6093 kilometers. I can use that unit factor now by putting the 1 mile on the bottom and the 1.6093 kilometers on the top. Cancel out miles. Awesome. So I have kilometers, and I need it to become decimeters. Well, kilometers is a metric prefix. 1,000 meters equals 1 kilometer. So I'm going to go there. 1 kilometer is equal to 1,000 meters. Cancel out my kilometers. I have meters on top, and I need to get that to decimeters. So deci is another metric prefix. 1 meter has 10 decimeters. So there we go. I'm going to cancel out the meters. I just converted miles into decimeters. So this needs to stay, right? Because that's what I'm looking for. Now, I covered up hours earlier. It's time for me to actually look at the hours. I need to convert hours into minutes. Now, we weren't given a unit factor here. Can you think of the relationship between hours and minutes? 1 hour is equal to 60 minutes. Are we feeling okay? So I can write that up here. 1 hour equals 60 minutes. Okay, so when I set this up, I know I have another step. I have hours on the bottom right now, which means when I set up my unit factor, I need to put hours on the top. The only way for me to cancel a unit is for the unit to be on the bottom and on the top. So it's on the bottom now. I need to put it on the top. So it's going to be 1 hour on top and 60 minutes on the bottom. I can cancel out those hours. The unit that's left with here is minutes. And when we look at this, every unit's canceled out except for 2. Decimeters on top, minutes on the bottom. Isn't that what we're looking for? This is why it's important to cancel out your units as you go. This sucker gets confusing, and if you're not canceling out your units, you don't know if you're done or not, okay? So, if you hadn't very clearly put the 1 hour at the bottom at the beginning, you would have probably put the 60 on the top and the 1 hour on the bottom, and you would have multiplied by 60 instead of divided by 60, and that would get you a very different number. Okay, so what I'm going to do is grab my calculator. 76.0 times 1.6093 times 1,000 times 10 divided by 60. This came out. Now let's look at sig figs. 76.0 has 3 sig figs. 1.6093 kilometers in 1 meter has 5 sig figs. This one has infinity. This one has infinity. This one has infinity because it's the definition of minutes to hours. So what's smaller? 3, 5, infinity, infinity, or infinity? 3. So 1, 2, 3. That 3 needs to become a 4. So it's not going to be 204. It's going to be 20,400. Or, in scientific notation, 2.04 times 10 to the 4th decimeters per minute. This would be the other. Oh, I'm getting excited here. I can't write and talk at the same time. Oh my gosh, pen. I'm gonna murder you later. The pen. I'm gonna murder the pen later. Okay. So this or this would be correct. So that's worst case scenario with dimensional analysis. Here's my suggestion. Go practice. Grab the chapter 1 discussion worksheet. Grab the chapter 1 practice worksheet. Go look in the textbook. Go look online. Go work on your homework. Practice these and let me know when you have questions, okay? Because this is going to be an important skill that's not going to go away all semester. But we are done with chapter 1, so yay!